Okay, these were the cylinder notes. So a cylinder, we want to think of maybe a can, like a can of peas, can of tuna, something like that. We have two bases. Okay, the bases are circles. So at the bottom, we have a circle. At the top, we have a circle. So we have two bases. Since those bases are circles, to find the area of them, the area is going to be pi r squared. The area of a circle is pi r squared. So there's going to be two bases, top and the bottom of the cylinder. The formula for the area of those bases is pi r squared each. Okay, then the lateral area, you got to think about the label on your can. So if you, again, have a can of peas or anything and you take the label off, the label is going to be a rectangle. Okay, the length of that label around the can is the same as the circumference of the cylinder or circumference of the circle. So it's going to be 2 pi r. And then the width is going to be your height. Okay, the area for a rectangle is length times width. So our lateral area here is going to be the length, which is 2 pi r, times the width, which is going to be the height. So 2 pi r each for the lateral area. So we have two bases, so we'd have to do pi r squared, and then plus pi r squared, and then plus 2 pi r each. Circles, top and bottom can of circles, the lateral area, you can think of a label on a can of vegetables or something. You take the label off, it's going to be a rectangle. The length of that rectangle is 2 pi r, and the height is going to just be the height. So 2 pi r times h gives us the area of that area. Okay, this diagram down here shows us what we have. Again, the cylinder is comprised of two circles, and again, the rectangle that wraps around the can, or wraps around to form the cylinder. Okay, example 1, we want to find the lateral area of the two cylinders here. So again, lateral area is the area around. It's the, again, if we're thinking of the can, it's the label. So the formula for the lateral area is 2 pi r h. Okay, the radius here is 3. So that's 2 pi times 3. And the height is going to be 8. Okay, that's going to give us 2 times 3 is 6. 6 times 8 is 48. So it's going to be 48 pi. So you can leave it as 48 pi. Okay, or that's actually the best answer. Or we can get a decimal by doing 48 times pi on our calculator, except we're going to end up having to round it. So it's going to be 150.8. Okay, which is approximately 150.8. That's not the whole surface area, that's just the lateral area, the area around the cylinder. Okay, and it's centimeters squared because it's area. Area is two-dimensional. So 150 centimeters squared, or we could say 48 pi centimeters squared. And the second one, it's a cylinder, it's just rotated on its side. Okay, so the lateral area is the area around the cylinder. Our formula again is 2 pi h, 2 pi r h, the circumference times the height. So that's 2 times pi times 1.5 times the height of 3. So that's going to be 9 pi. So 9 pi feet squared is your best answer. Okay, but if you insist on making it a decimal, it's going to be 28.3, approximately 28.3 feet squared. This was A. Example 2. So our total area or our surface area, and total area is the same as surface area. Okay, it's going to equal the base areas. So there's two bases. So the base areas add those two bases together, the two circles of the area of the circle on the bottom and the area of the circle on the top, plus the lateral area. So let's find the area of the base. The area of the base, so the base is a circle, so the area is pi r squared. They're giving us a diameter. So the diameter is 8. So the radius is half the diameter. So the radius is going to be 4. It's going to be 4. So our area is going to be 16 pi. 16 pi should be about 50 something. 50.2. 50.3. So it's going to be approximately 50.3 again, centimeters squared. Okay. And again, there are two circles, one at the top, one at the bottom. So the area of the bottom is 50.3. The area of the one at the top is 50.3. So we have two of them. Okay, now we got to find the lateral area. Lateral area, the formula is 2 pi r h. So again, it's the circumference, the length around the cylinder, times the height of the cylinder. The base area times the height. Oh, I'm sorry, we're doing surface area. I'm thinking ahead. Okay, so 2 pi r h, the length around times the height. That's giving us our surface area. Okay, so 2 pi, and the radius is 4, it's half the diameter, and the height is 10. So we get 10 times 4 is 40. 40 times 2 is 80, so we have 80 pi, okay, which is approximately, I don't remember, 251, somewhere in there. 251.3 centimeters squared. So here are the two base areas. Here's the lateral area. We add them together. So that's 50.3 plus 50.3. It's 100.6, and then 100.6 plus 251.3 should give us 351.8 centimeters squared. Right, so that is our total area, or better called the surface area, the area around the cube. So if you needed to wrap this as a gift, you would need 351.9 cubic centimeters, or centimeters squared, square centimeters of wrapping paper. This isn't the volume question, this is surface area. So that's surface area. Volume. Volume is just like the volume of the prisms. It's the area of the base times the height. In this case, the area of the base is pi r squared because the base is a circle. So volume is going to be pi r squared h. Right, so it's the area of the base times the height, just like the prism, but the area of the base of a cylinder is pi r squared. So in our example here, we use our formula for volume pi r squared h. The radius, this is the 14 is the diameter, so the radius is half the diameter, the radius is 7. So the area of the bottom circle here is pi times 7 squared, and then we want to multiply by the height. So again, you want to think of this as a swimming pool. I covered it up. Okay. Think of an infinitely thin layer at the bottom of the swimming pool. That's going to be your pi times 7 squared. That's the area, the amount that you're covering of the pool, the amount of the bottom of the pool you're covering. Okay. And then you want to know how much water is in it. You're going to need to multiply that area by how high you want the water to be, or how high the water is. So that's going to be 196 pi So multiply all those together, we should get approximately 615.8 centimeters cubed, right? 7 centimeters times 7 centimeters is 49 centimeters squared. 49 centimeters squared times 4 centimeters is 196 centimeters cubed. And then 196 centimeters cubed times pi gives us approximately 615.8 centimeters cubed. So that's it for the notes on cylinders.